Okay, how are we going to set this one up for elimination? And by the way, you have to decide for yourself, do I want to eliminate the x's or do I want to eliminate the y's? And you can see that if you do it differently than someone else, you're going to get the same answer if you both do it right, okay? It doesn't matter which one you eliminate, but which one do you want to try and eliminate here? When you look at 4 and 6 and you look at 6 and 9, can you find the lowest common multiple? What is it? 18, and you want to eliminate the y's. Okay, and that works. Or if you decided you wanted to eliminate the x's, what's the lowest common multiple of 4 and 6? It would be what? 12. Oh, interesting. Okay, so what do we have to multiply the top one by? You said the lowest common multiple of 6 and 9 is 18. That's because 6 goes into 18 3 times, 9 goes into 18 2 times. So what do we need to, and we need them to be opposite signs, right? So what are we going to multiply the top one by? 3. What are we going to multiply the bottom one by? -2. Do you guys see why? I mean, you could have said -3 and +2, but you didn't, so we went with hers, okay? Now we're multiplying this whole thing by 3. 3 here, 3 here, 3 here. What do we get? 12x minus 18y equals 30, right? What do you get for the second one if you multiply everything by a -2? -12x plus 18y equals, what is it? -16. Okay, what happens now? We eliminate, we add. What happens? What do we get? 0. Oh, that's 0, that's 0. These both eliminate. 0 equals what? Is that true or false? False. There's no variables left. What does it mean about the two equations? Is there a solution? Why not? The lines must be, the lines must be parallel. So since this is a false statement, it means there's no solution, which means the lines must be parallel. Is there a way that we could check it? Is there a way to prove that they're parallel? What do you know about parallel lines? Same slope. They must have the same slope. Is there a way to check the slopes? What could you do to check the slopes? Y equals mx plus b form, and then the m should be the same, and the y-intercept should be different, right? So if we go up here, this is going to be our checks then. 4x minus 6y equals 10. How do we get y by itself there? Y equals, how would you reduce that? -4, 6, or negative divided by negative is a positive, 2/3 x, and then we'll just, what should we reduce that one down to? -5/3? Just reduce, right? Okay, that's for number 1. We need to do that for number 2. I'm kind of debating, I think I have more room up here actually. So I'll do the second one. Check for number 2 up here. 6x minus 9y equals 8. What should I do to get x by itself, or y by itself, sorry? Minus 6x, negative 9y equals negative 6x plus 8. Divide everything by negative 9. And we get y equals, is that still 2/3? Yeah. 2/3 x minus 8/9. So I can see that the y-intercepts are different and the slopes are the same. But again, that gets back to fractions. Got to be able to reduce the fractions. 6/9 reduces down to 2/3. So the slopes are the same, and that's how we can tell that there would be no solution, because if I have two lines and their slopes are the same, they're parallel, they have different y-intercepts, right? Yes. Nope, I wouldn't get a different answer. I would get the same. Because if I put, you're saying here, would it be different if I wrote 10 minus 4x? No, because I would divide by -6, -6. I would still, this number attached to x is still the slope. So I could write this as y equals -5/3 plus 2/3 x. It's still the same thing, and the slope goes with the x, right? It's the coefficient of x. That would just be this one rewritten, changing the location, commutative property. Okay, let's look at this next one, example 7, and tell me what would we want to eliminate here? What variable would make sense to eliminate? The y. Because why do you think the y is easier to eliminate? Yeah, because I already have this one negative. I don't like to multiply by negatives if I don't have to, right? So we're going to multiply the top one. Everybody agrees that we could multiply this one. Multiply by 3, right? And so what do you get if you multiply by 3? I'll write it down below. 3 on both sides. Okay. Now I have 6x minus 9y equals 15. That's the second one. Okay. And what do we get now if we add these? So 6x plus 6x is 12x equals 30, right? Because we're adding those together. X equals 30 twelfths. Yeah? 30 twelfths? Yes, reduce, right? 3 goes into this one, 10 times 3 goes in here, 10 fourths, 5 halves. So reducing, right? Now, I said one thing you could do is you could check them and solve for y at the same time. If we know that x equals 5 halves, I'm going to do check number 1 by plugging in 5 halves for x. 2 times 5 halves plus 3y equals 5. What do you get there? 5 halves times 2 is 5. Plus 3y equals 5. What do you do now? Subtract 5. 3y equals, oh, this is like the problem we did earlier. Y equals 0. Now for check number 2, as long as you make sure you use the second equation, you can plug them both in, or you could do what I did and just plug in x and solve for y. Either one. So maybe let's try check 2 like we were doing, like some of you were doing. Check number 2, because you want 2 of them. Take the second equation, 6 times 5 halves plus -9 times 0 equals 15. And let's see if that works. So this is 0, right? What would that be? 6 times 5 halves. 15. So here we get 15 plus 0 equals 15. 15 equals 15. For this one, I put the question mark because since I'm plugging in both numbers, I don't know if it's going to work. And then finally, I'll say the solution is, what is the solution? 5 halves, comma, 0. So So we got y equals 0. We got x equals 5/2. And it worked in both equations, right? If I plug in x and I solve for y, that's pretty much, nearly the same thing as plugging them both in to see if it works, right? I didn't know what y was, so I had to take a chance solving for y. But you can put this solution back in. It's more important to make sure it goes into the second equation, okay? I'm going to project